Good morning, everyone. My name is Sterling Brooks, and today I will be delivering a presentation on airborne wireless communications. I am currently in ECE 645 wireless networks at New Jersey Institute of Technology, and my instructor is Dr. Byron Chin. As far as I can remember, it has been customary to put all electronics on airplane mode during a flight to prohibit the transmission and reception of data to that device. For a long time, the FCC/FAA would only allow the use of these said devices, cell phones, iPads, Kindles, etc., anything that can really transmit and receive data during flight if they were placed in airplane mode, due to the misconception that if devices were allowed to transmit and receive data during flight, it could negatively affect the transmission and reception of airplane essential devices such as its navigation and communication system. And with the upgrade of technology, with the influx of 3G, 4G, VoIP, and wireless internet, we began to change that mode of thinking. And today, we currently have Wi-Fi, and there are places in the world that have mobile activity on cell phone on airplanes. Now, in the U.S., companies such as GoGo, Aeromobile, and On Air partnered with carriers such as T-Mobile to offer in-flight calls, phone calls, text, mobile activities, etc. And so, to be clear, there are two major types of airborne wireless communications that are available to uh, consumers today. There's in-flight internet via Wi-Fi and in-flight mobile phone communication. Now, we're going to move into the different types of communication. First off, there's 1G, or first generation technology, which are associated with, phones of this caliber. You remember the phones that you had to have in your briefcase uh, back in the day? Yeah, these are them. They're first generation cell phones. They didn't get too much. Their data rates were pretty low, and they were strictly made for voice calls. They utilized frequency modulation, strictly frequency modulation. So each frequency band was available to one user at a time. So it didn't have too much bandwidth. It didn't have too much user capability. And as time went on, we increased and we moved on to our second generation technology, which is known as TDMA, or time division multiple access technology. And we then began to use and utilize frequency modulation and time modulation. So we vary the frequency and time so that we can get more users, a higher data rate, and etc. See our data rate increase from 64 kilobits per second to from 2.4 kilobits per second in our one generation technology to roughly between 6.64 kilobits per second and 144 kilobits per second for our second generation technology. And they were custom with our common Nokia phones, and they were again predominantly voice communications. They did have a little bit of data though. And then we move into our third generation technology, which before we move into our third generation technology, the importance of 3G, 4G is that it began to really, we began to see mobile broadband, you know, 3G, 4G phones, they are the epitome of mobile broadband. They are made, increasingly and strictly for 4G, as far as 4G is concerned, strictly for data communications. And with data communications, digital communications, we use VoIP, you know, as our primary medium for voice calls. You know, as we move on, our third generation, the explanation of a third generation, it utilized the structure of code division multiple access. And this is a technique for sharing the frequency spectrum. Multiple users are assigned radio resources using spread spectrum technology. Although all users are transmitted in the same RF band, individual users are separated from each other via the use of orthogonal codes. Now, What that means is that we took what we had in our TDMA and we varied the frequency and the time, and then we also added in what is known as PN codes or pseudo noise codes. And what this does is when you modulate something with a PN code, you have to demodulate it with the PN code to get the data that you want, right? Now, unfortunately, our original CDMA structure was considered to be about 2.5G. Not it was not necessarily up to uh, the standard of what 3G is held at. Now, we when we upgraded a little bit, or to a wideband CDMA, EVDO CDMA 2000, basically the upgraded version of our original CDMA structure to make it so that we can accommodate more users and a higher data rate. We then began to see our true 3G structure here, and they our 3G structure is our third generation technology is commonly accustomed with the influx of our first smartphones, as you can see here in this picture, this diagram, and also as you can see, this is a illustration of how it sends its data. You have your control bits slash chips, which are your pilot chips and your 64 chips. Those are the things, your Mac chips, and then you have your data. So you can send 1600 bits of data roughly in 1.67 milliseconds. And you see our data rates increase from our previous is steadily increased from, 1G technology was around 2.4 kilobits per second. Our 2G technology is roughly between 64 and 144 kilobits per second. And now we move to increase for our 3G technology, which is between 144 kilobits per second all the way up to 3.1 megabits per second, a tremendous increase. Okay, as we move into our 4G technology and our current technology, we introduced orthogonal frequency multiple division access. This structure is commonly seen with our smartphones, iPads, things like that today, right? So OFDMA is a multiple user version of the popular orthogonal frequency multiplexing, or OFDM, digital modulation scheme. Multiple access is achieved in OFDMA by assigning subsets of subcarriers to individual users as shown in the illustration below. This allows simultaneous low data rate transmission for several users, right? So the changes to take note of from as we increase from first generation all the way to our fourth generation. Our first generation, they had specific channels for specific users. Second generation, they did the same as well. This particular channel only allowed this much data for this user. Now, for our 4G structure, it is a little bit different. Each user is allowed to utilize the entire 4G network for its reception and transmission, given that it shares it with other users, meaning it doesn't have a set amount of resources that it can use. If no one else is on the network, it can use the entire network. If thousands of other people on the network, it shares the network with those other people. Okay, and the major advancement for 4G, like I said before, is really wireless LAN, mobile broadband. And as you can see, our data rates again began to skyrocket. It's now at 100 megabits to 1 gigabit per second. And here is an illustration of, just the complexity of these different structures. FDMA, as you can see, as I illustrated before, you vary the frequency, but they all transmit at the same time. For our TDMA structure, you vary the time slots, and you vary the frequency. They both change, right? And then we move into our 3GMA structure. You vary the frequency, you vary the time, and then the PN codes separate each additional block, right? And then as we move into our 4G, as you can see, it's more complex, and it is more complex so that we can accommodate more users, higher data rates, so that companies and corporations can appease the consumer, so that they can meet the demand. Okay. Now we move into our next type of wireless communication, which everyone is pretty much familiar with. Mostly everyone, has a form of Wi-Fi today or wireless internet, right? And um, our our wireless internet, known as Wi-Fi, is simply a trademark phrase. It's defined as wireless local area network or WLAN, and these are basically products that are based on the IEEE or Institute of Electrical Electronics Engineers 802.11 standards. And it allows us, basically, what that is saying is that the 802.11 standards define Wi-Fi, what it is and what it's supposed to be. It has to be held up to a standard, as far as its power, its reception and transmission, the way it sends and receives data, all of that. And, today it allows us to connect to the internet on our phones, on our computers, on our portable electronic devices, or other PEDs. And this is another type of communication. And all these communications we see and interact with today. But airborne communication, it addresses taking these forms of wireless communication and giving it to people as they fly, as they fly from one location to another on the airplanes, whether it be for family or recreational uses or work. Okay, so the one of the major problems, as addressed before, is problems with cell phone use in flight. Right? Normally, you Normally, you see when you get on a plane, they tell you to put your phone in airplane mode, and this is this is done because it is a possibility, or the FCC believes that it is a possibility that the transmission and reception given from everyone's cell phone on the plane can negatively affect the communication and cause a safety hazard. Because you can imagine, if you know your navigation communication systems don't work, are pretty much left hanging out there. And they safety is a big issue for these companies, and they don't want to take any chances, really. Okay, so the real problem with this, right? So the real problem is that normally, your phone with the transmission and reception shouldn't be a problem. But as you get further and further out of reach from a cell tower or base station, your phone is continuously trying to pick up a network. And so what it does is it increases its transmission power and causes more interference. Now, this happens when you fly above 10,000 feet or so, and your phone is constantly roaming, constantly looking for a tower and network to connect with, right? And with this increased, with this increased electromagnetic interference, the FCC sees it as uh, as a safety issue, a safety hazard, right? And so today, it is customarily required for everyone to put your phone on airplane mode. Now, this also protects you. It ceases the transmission and reception of data through the network, but it also saves your battery life, because as this power is increased and you are your phone is currently looking for a network during your entire flight, of course, your battery dies faster. Anyway, supporting evidence, supporting argument for this is, uh, outside of this being a safety issue, the FCC also believes that it uh, that by putting your phone and portable electronic devices away and in airplane mode during taxiing, especially, and takeoff and landing, which is where 80%, more than 80% of accidents happen, um, you it makes the people on the plane more quiet and attentive, you know, to when they're giving safety information. They are more prone to pay attention and not be in their phone if you require them to put it on airplane mode, right? And also stops them from annoying other passengers, right? So as we move on, let's get right into it. How does in-flight communication work? Well, there are two ways to go about this. We have satellite communication and both and air-to-ground communication, which they are just like they say. We first start off with air-to-ground communication. Now, air-to-ground communication is just as illustrated below. We have networks that we interact with on a daily basis with our phone today. You make a call, you're inside of, the range of a cell tower, and you connect to the network. So basically, what air to ground communication does is instead of focusing on uh, making a base station or making a cell or the reception of a cell tower as wide as you can, we point it basically towards the sky, right? And so as the plane flies on track, we have, for all intents and purposes, a network in the sky, right? And so the plane has an antenna on the bottom for reception, and it communicates with these base stations, these network cell towers as it flies on its predetermined route, right? And so the pros of air to ground communication is that it's cheaper. It's much cheaper than satellite communication because at this point, uh, base stations are there are there are an abundance of base stations already out there. You just have to modify them to fit fit your needs. You know, fit your needs. Now, as far as the cons, that of course data rates are lower than communications, and also with this network in the sky, we don't have base stations in the ocean. So we can't really point that network up and make it and implement it in the sky. You know, point that network towards the sky. So it can't be used for overseas flights. It'll pretty much be only domestic and only when planes are flying over the ground. Now, as far as we move into satellite communication, uh, basically you have an antenna on the top of the plane, and satellite is the middleman. It connects with the network, and it bridges that gap, that connection to the plane. It's the middleman. It sends and receives data between the plane and uh, your network or internet service provider, right? So I put two illustrations here to just to show, that just to illustrate that the same process is done for in-flight Wi-Fi as is done for in-flight mobile connectivity. You All you do is you connect to the internet, or you connect to your your uh, your mobile service provider. It is the same. It's pretty much the same exact process. Your satellite is still the middleman. Okay, so pros. All right, it is most definitely more accessible than air to ground or ATG. We can implement satellite communications anywhere on the planet, right? Um, and of course, it has higher data rates, much higher data rates. Whereas air to ground is roughly around 9.8 megabits per second. Satellite communication can reach up to speeds of 10 megabits per second, 50 megabits per second, and higher. As far as, and our cons are Our cons is that, of course, it's more costly than air to ground because you have to launch, you have to you have to implement very expensive software and hardware onto planes. You have to communicate with base stations and cell towers, but also too, the satellites are the one of the most expensive things that you have to launch into orbit. You know, so that you can connect these planes to either the network, the internet network, or your phone service provider. And then also too, with these satellites, they spread over a large geographic area. So if several planes are in flight in a specific area or route, um, these planes, and they have the same service provider. These planes have to share their data rates, um, and they have to share their like I said, they have to share their data rates. Okay. Now, what makes all of this possible, whether it be internet Wi-Fi or internet mobile connectivity activity, is the use of a picocell, right? And not sure if everybody's familiar with picocell, but I'm pretty sure everyone is familiar with a macro cell. And a macro cell is what we interact with every day on a daily basis. This is what allows us to connect to our network, right, with our cell phones. Now, a normal macro cell is about 20 miles in diameter, and like I said, this allows us to connect to our network. When inside a macro cell, we have network connectivity, right? A picocell is just a smaller form of that. It's predominantly used in buildings and help to boost signals where signals are, where they're spotty, sketchy, you know. And this is basically a mobile base station, and it supports about 100 users or so. And here in this diagram, it's just some small fun facts, small cell basics, um, to help you get more familiar with the different types of cells that you may interact with um, in our daily lives. And so this picocell, whether it be for in-flight internet or in-flight mobile connectivity, either way, these cells are placed throughout the plane, and so users can use those cells, or you connect to those cells and essentially connect. You know, those cells are connected to the plane's antenna, which the plane's antenna is connected to either the underbelly or the top of the plane, and it uses either air to ground network connectivity or satellite connectivity connect to the network. Right. So here are some of our major providers um, in this day and age. I'm pretty sure you guys have seen some of these before. Uh, these are major providers of in-flight internet and mobile activity. Right. So we have GoGo, Viasat, Row 44, Panasonic on here, and I will begin to give some fun facts about them. Now, GoGo is definitely the leader in air-to-ground internet service in the US of A, right? And they, uh, as of right now, they are working on their 2Ku and their ATG4 network. They're working on implementing that, right? Because although they are the leader in air-to-ground internet service, they don't strictly have air-to-ground internet service. They also have satellite service, so they use pretty much a hybrid system, right? And that's why I said they're promoting their 2Ku and their ATG4 network. So 2Ku is basically two Ku band transmitters. Well, one Ku transmitter and one Ku receiver. For the Ku frequency band, which we'll talk more about that later on. But they pretty much get fair data rates. They get about 3.1 megabits per second to 9.8 megabits per second. With the ATG network, that's roughly 1 to 2 megabits per passenger. With the satellite, their data rates are a little bit higher, but remember, with that, um, any other planes that are on their, that same route, it's shared, because satellites again cover a wide geographic area. We move into row 44. Row 44 again, it it has this is predominantly an in-flight entertainment uh, company, and what they do, they're pretty much a device-based service. So the difference between a device-based service and normal in-flight internet service is that we that they basically they allow streaming to your device instead of, you have those, sometimes on airplanes you have panels on the back of the seat, and you can access your internet or movies or anything like that, um, from that panel on the back of the seat. Well, device-based companies, they don't do that. They allow you to directly plug in with your device. They don't already have equipment for you to use on the plane. Anyway, um, row 44, they provide service to roughly around 265 commercial airplanes in North America and Europe, and their data rates are, you know, pretty much comparable to the competitors. 40 megabits per second to a plane, roughly 1.5 to 2 megabits per passenger if all passengers are using the internet service. Viasat is definitely the leader in satellite communication, and but see, they don't only delve in in-flight internet. What they do is they also do residential internet, right? They do residential internet, so they have, they have residential consumers with satellite internet, satellite TV, phone, things of that nature, right? But their data rates are much much higher with their Viasat 1 satellite, and if I remember correctly, they use a Ka band. Um, they use Ka band transmission, and they get pretty good reception, about 10 to 15 megabits per passenger. But remember, with this 140 gigabit per second data rate, this is also shared with the residential homes and the airplanes that are in the vicinity of the vicinity of the transmission and reception of their satellite, right? Okay, and move on to Panasonic. Uh, Now, Panasonic and Aeromobile. Aeromobile is a subsidiary of Panasonic, and basically Aeromobile is Panasonic Avionics Corporation's segue into the international community, right? So Aeromobile is a UK-based mobile service provider for the aviation industry, and basically it does the same thing as all these other companies. It provides in-flight entertainment and Wi-Fi, and in-flight entertainment, internet, things of that nature, right? Um, and we move on to our last one, which is SITA and On Air, which SITA is a predominantly international company. However, uh, I just wanted to address, I wanted to address the predominant, the major providers here in the U.S. and bring in one international company so that you can, roughly see that the U.S. is the U.S. and international community is on par for all intents and purposes. However, the international community, what they are doing and beginning to do, they are beginning to work with um, mobile connectivity on flights, as opposed to the USA is strictly sticking to um, simply internet and entertainment as of right now, right? Okay, so SITA on air does about 50 megabits per second, and they use the Ka band satellites. So in the U.S., there's only four major cell phone providers that partners with the internet service, so that their customers can have free in-flight text/calls, um, through their internet service, and that is T-Mobile. T-Mobile partners with GoGo. Now, that does not mean that you cannot, with these other service providers, that you cannot use their internet service. You can use their internet service, but for a fee. T-Mobile is the only one that partners with a specific internet in-flight company, and does not make their basically foots the bill and does not make their users at least pay on the back end for in-flight mobile connectivity. Okay. So the airlines that partner with these companies here in the USA are, as you can see, GoGo definitely has most of the consumers. I mean, most of the airlines. American, Virgin, Delta, Alaska, United, and we have the other companies. They don't have as much, but one thing to note is that every plane doesn't necessarily have Wi-Fi. It's all in different makes and models. Some have more upgraded version, faster internet than others, and some have better services than others, just generally. As far as Viasat and JetBlue, we have to note, fun fact, JetBlue offers free Wi-Fi to all its customers, not just any customer that gets on JetBlue, they offer their internet free. And as far as right now, JetBlue via Viasat has the best internet service. However, GoGo is the most abundant. So, you have your pros and cons. And of course, all these things go into play as we move into our comparison. GoGo, of course, as we mentioned before, is the leader in ATG communication, and they are currently working on that ATG4 and 2Ku communications. Their prices roughly range from about $5 for an hour of internet activity to you can get a yearly subscription for about $660. And they, like I said, they partner with T-Mobile, and their data rates are 40 megabits per second, which again ranges down to about 1 to 2 megabits per passenger. Viasat, of course, Viasat, like I said before, it's leader in satellite communication. It has the highest speed and the biggest spectrum with the use of Ka-band antennas, which we noted at 400 gigabits per second. However, the downside to that is as to share its bandwidth with residential consumers, as well as the in-flight entertainment, in-flight companies, so as well as airline companies that it partners with. And we move on to SITA, which is about 50 megabits per second, which they use predominantly satellite communication. Everybody pretty much uses predominantly satellite communication except for GoGo. Well, to be more precise, they use predominantly satellite because satellite is better, however more expensive. But they use either satellite or a combination of both satellite and air-to-ground communication, which definitely GoGo uses, a little bit more air-to-ground communication than others. But all of these companies, except for pretty much Viasat, use a combination of both air-to-ground and satellite communication. And as I stated before, with the Ka, Ku, K, these are all frequency bands, right? So as you can see with this graph here, the frequency band of your Ku spectrum is from roughly around 12 gigahertz to around 18 gigahertz, right? So that's the spectrum. So with a bigger spectrum, you have a higher throughput or higher data rate. The antenna size is a little bit smaller, but on the negative side is more susceptible to bad weather, right? So you have your give and take. If you use your Ka-band, which most definitely has a bigger spectrum and has a higher throughput, a smaller antenna size, it will be susceptible more to, bad or inclement weather, right? And so as we compare these things, I say that these people use a KU band, a KA band, a K band. Um, you know, it all depends on how they can cope with uh, negative or inclement weather. It all depends on how they utilize their technology to give the consumer the best in-flight internet and mobile connectivity. Right. And as far as right now in the U.S., I see GoGo personally um, more often than I see these other companies. And I wouldn't necessarily say it's the best, but it is roughly most reasonable. But as you can see, it depends pros and cons. You have to weigh your options. You have to also assess what you have, depending on what airline you like to fly. Is also depending on what internet service you will have. Okay. So as far as improvement, um, like I said, all these companies are working on trying to get a higher bandwidth and data transmission. That's why they are using instead of normal instead of using an L band, um, instead of using the L band, which has 1 to 2 gigahertz, they are moving towards the KA band, right? As I showed before, KU is from 12 to 18 gigahertz. The KA band is from 27 to 40 gigahertz. They are also working on improving their communication and improving their technology. Now, for companies such as GoGo, who were predominantly air-to-ground communications in the beginning, most companies, if not all of them, are moving towards being predominantly satellite communications. However, GoGo is still sticking with the hybrid approach as of right now, and I would have to say that would be the best option, because even though air-to-ground communication has uh, a lower data rate than satellite communication, it is, when inclement weather, when you have inclement weather, that affects the KA/KU band more heavily than other frequency bands. Um, it's better to be connected in 2 points as opposed to just one via satellite. So there we have that. And in conclusion, right? As in-flight communications and entertainment become more widely recognized and desired by the consumer, providers of this service seek to meet that demand. As we have seen, a steady increase of a desire for this service has caused a boom in the amount of planes and airlines that offer it. And soon we'll be able to be just as connected to the world in the air as we are on the ground in our everyday lives. And that is important. That is the goal, the guide for airborne wireless communications. We desire to be connected just as we are on the ground and the air when we're traveling, connected to work, connected to our family, connected to our friends, to our personal circles. We still want to be connected and in the loop, whether we're traveling or whether we're at home. And that is the true basis of airborne communication. Now, thank you guys. This will be the conclusion of my presentation. Just a note, fun fact. There's something that there's another form of entertainment that I've not addressed, which is called intranet, right? Intranet, which they already have your files downloaded to a server or something like that, and they bring it on a plane. So instead of having to stream it via Wi-Fi, you stream it from this server, from this data bank that is already placed on on the aircraft. Anyway, again, I conclude my presentation, and I thank you guys for listening. I thank you guys um, for paying attention and giving me your attention. Again, thank you. Have a good day.